Hi friends, today in this video I am going to talk about Oracle database. Oracle database is basically the one of the most demanding database which has started by Oracle Corporation in 1971. So even when you are starting your career as Oracle database, in most of the interview you will get so many questions from Oracle database architect. So in that perspective also, and even for learning Oracle database, this is the one of the most demanding topic that you have to must learn with deep understanding. So I am going to explain with my personal experience on a Oracle database, because I am a database administrator. So with my personal understanding, with my personal experience, I am going to explain the whole architecture. So yeah, first of all, whenever any end user wants to connect or a database, so it connects through any client machine, or through any end user application, or even through SQL developer. There are multiple platforms. From there people connects to the database. So client machine, it will create a user process, and between user process and server process there will be a listener will have information about the host and port of a database. With that, it will decide which database it has to connect. So it will generate one dispatcher request. That dispatcher will send that request to the server process, and server process are when you create a database, by default it creates a dedicated server process. And server process basically sits on Oracle server side. So when we create a database, it will get created. By default it will be a dedicated server process, and for dedicated server process it will create a PGA, that is called program global area. But if you are choosing a shared global area, for that it will create UGA, that is user global area. So server process is basically responsible for making that connection to the database, because it's interact to the database. So it will send that request to the database, like if we are firing any select statement or any SQL on a database. So from server process it will go to a SGA is a shared global area. Basically is the largest part of the database instance, and the database is basically combination of instance, background process, and the physical files. So physical files are basically data file, read log file, and control file. So these are the physical files. And yes, SGA is also the combination of different subcomponents. So in that, whenever that request will come from server process, it will go to share pool first of all. And in share pool there are two subcomponents. That one is library cache and another is dictionary cache. Library cache is basically information of most recently executed SQLs. So most recently executed SQLs are basically when that request goes from server process to SGA, it will do the syntax check. Like if that query is select star from employee, so syntax it will validate from there. Like if you execute select from employee, it will not execute, because the syntax is missed here, like star is missed. So it will not it will throw the error. So that part is happening from library cache, because it will do the syntax check, semantics check, and privilege checks are happening on share pool itself. So when the syntax check will happen, after that it will it will validate. If it will find that yes, this SQL is present on the buffer cache, then it will fetch the that particular query output, and it will return to the, through server process, it will return to the client machine. And that's the same process is getting followed for in case if that particular SQL is not present in library cache, then it will create a execution plan for that. And also, like yes, data dictionary cache is metadata of a database, like it will have object information like table views are stored into this. So it will do the validation from data dictionary cache, as well as when library cache will not find that particular SQL, it will generate a new execution plan that is basically goes for hard parsing. And there is two words that we use in a database when any SQL get executed on a database side. It will go to soft parsing, either it will go to hard parsing. So soft parsing is the first case where it will find the SQL from the library cache itself, and then it will fetch the data from memory, buffer cache memory, and it will return to the client. But in hard parsing case, it will create a new execution plan and it will go for optimization. In that, it will it will check from the buffer cache. If that not there, then after creating execution plan, it will then the background process will come into the picture, and DB writer will fetch that DB writer will fetch that particular data as per the query request. It will fetch the data from the data file, and it will return to the library cache, and library cache will buffer cache, and then DB buffer cache will return that to server process, and server process will return to the client. So that's how it works. So the next is as we know, buffer cache is doing all the things, whatever the queries are coming, it is getting executed in buffer cache itself, and it stores the in case if we are executing any like a database change statement queries like insert or create or something like any DML. So in those situation, it will do the changes on the data, and that in that situation, read log and online read log and buffer read log buffer will come into the picture. So there first of all, buffer cache will change that after doing the modification on the query, it will get converted into a dirty buffer, and that dirty buffer will get written to the online read log. It might be uncommitted transaction, or it may be a committed transaction. So both can be possible, and from read log buffer, it will get written to the read log file through log writer. Log writer is responsible. It's also a background process. These are basically a mandatory background process. Background processes are basically two type: mandatory background process and optional background process. So library cache is a mandatory background process which is responsible for copying online read log buffers to the online read log files. So here read log files are basically two online read logs we can create, like as per need we create that read log files. So first it will start writing to read log 1. After that, once it will get filled up, it will done the online read log switch will happen, and then it will start writing to second online read log. So that's how whatever the change transaction change modified data will come from online read log buffer to the read log. It will get written to log 1 and log 2, and similarly till the time after that it will get written to through archiver process. There is a optional background process that is called archiver. With the help of that, it will get written to the archive read log that will use for our backup and recovery of our database in case our database fails or it get crashed for any reason. So that will be used for recovery. So yeah, so the next is ASMON. If we focus of our mandatory background process, so ASMON is system monitors. ASMON is basically used for instance recovery and yeah, even for temporary table space management also it will be responsible. PMON is responsible for our transition rollback, and for PMON is process monitor which is responsible for user session recovery and doing the cleanup or even rollback statements. This is responsible for making those cleanups on database. And yeah, checkpointer is a background process which is updating the SCN number to data file and on control file. Control file is a brain of a database which will have information about the database creation and all the data file information and detail about the database. So this control file will be considered as a brain of a database. So SCN number, whenever SCN number is getting generated very frequently through whenever the checkpointer is occurs, that time SCN number is getting generated and that is getting updated to the header of a data file and control files. So yes, there are some condition when the log writer writes whenever the online read log is more than 1 GB or it's 1/3 full, or even every 3 seconds log writer writes the data buffer read log buffers to the online read log files. So similarly there are few conditions on that basis DB writer writes those online read logs to the online buffer cache changes to the data file. Like whenever the buffer cache dirty buffer is filled up, or even there is no space left in the buffer cache, or even whenever any truncate or any drop statement, table space drop or truncate statements are getting executed, or even for every commit basically the DB writer writes, and log writer writes before the DB writer. So that is also one condition when log writer writes. So these are the condition when the log writer writes. So apart from, there is a parameter file and password file. Parameter file is basically a file which will it's a file which stores the information of every component which is showing on the figure as a shared pool, SGA max, SGA target, and buffer cache, read log, Java pool, large pool. This parameters, these components are declared into a parameter file with how much size we need it. So those things are declared. All the instance related parameters are declared into parameter file. So parameter files is two type, like one is P file and the another is SP file. P file we called it init.ora file, and this file is basically a static file, and SP file is a dynamic file. So if we are doing any change in p file, for that we have to restart our database. And basically for starting our instance, p file is responsible to allocate the SGA. So p file is equally important. Without p file our database cannot run. And the next is password file. It is used for user authentication. So this is the whole thing about the database. In that, data file is actual physical file, and read log files are all the change transactions are getting stored into that, and control file already I explained it. So this is the whole thing about the database. And this all components are like very much important. Yeah, Java pool, basically this Java pool are getting used at the time when we execute a statement with JVM or Java related statements. For that case, Java pool is getting used, and large pool is getting used at the time when we are performing any Arman backup with higher IO, and for our recovery, yeah, for database recovery. In those conditions, large pool is getting utilized. So this is the whole database instance that I have explained. If any doubt, please comment below. Thanks for watching till here.